Okay, continuing on with the Pong game. We see that our sprite has a texture and a vector coordinate. Pretty much every sprite is going to have both those things. So we're going to do some refactoring here. Remember, refactoring means to change the way the code works, so it does exactly the same thing, but in a better way somehow. More efficient, more readable, more extendable, whatever. So we are going to use a class of our own. We've gotten used to using classes that are provided for us, like the game, or the sprite batch, or textures, or the console class. But now we're going to make our own, and we get to call it what we like. I'm going to call it sprite. So every sprite has a texture 2D, and that is the sprite's image. Try and keep these names abstract. Remember, every sprite is a different thing in your game. So if I were to say ball image right here, it wouldn't make sense because our bat's going to be a sprite as well, and then your bat would have a ball image, and that makes no sense. So keep it generic. Texture 2D image, vector 2 for its position. Now we don't need these two because the ball is going to be a sprite and have those two things. But as soon as I delete that, of course, we'll get a bunch of errors because those two variables are used through our code. So a class doesn't exist on its own. You need to create an object of that class. So after you've made the class, we then say sprite ball. Oh, you know what? I could actually put the colour in here as well. I'm going to call it a tint and give it an initial colour of white because that's typically what colour you would use. So we have a sprite called ball, and we're going to create a new sprite to put in there. Now every time we use the ball position, we'll do ball dot position instead. That's because the variable happens to be called position. So ball dot position lets us access the same thing. Let me rebuild that and see if error goes away. No, what's inaccessible due to its protection level. These variables or members are protected. They're private. The word private is implied. So we need to make them public if we want to be able to access them from everywhere else. So ball dot image. You can see the ball has an image. Instead of ball image being one thing, we now have a ball with an image inside it, and a ball with a position, etc. And finally in the draw, use the ball's image at the ball's position. And we're also going to make it use the ball's tint. So if I've done my refactoring correctly, it should do exactly the same thing. It does. By the way, notice that it will go off screen. We've not coded anything to make it stop. So that's refactoring. Now we can make sprites for other things. Also, that ball is kind of slow. Let's make it plus equals. That's a compound assignment 4. A compound assignment is a shortcut. Plus equals is the same as saying make it equal to what it was before plus whatever value you put in. Make sure you get it the right way around though. Plus equals means add 4 on. Equals plus means make it equal to the positive value 4. You don't want that in most cases. Okay, so it's going to go a bit faster, but still do the same thing. That wasn't a refactor, that was just a change to the gameplay. But hang on a minute, couldn't we put these two in a variable as well? And the answer is yes. We could have another public vector 2 for its direction. And when we initialize it, ball's direction will become a new vector 2 with the values 4 and 4. And then we can just add all of that one at once. The ball's position gets added on to by the ball's direction. In other words, the x and y the x and y directions get added on to the x and y positions. Still the same. That was a refactor. Okay, now what else can we do? oh yeah, the ball going past the boundaries of the screen. So during the update, that's when collisions happen, and a collision with the edge of the screen can be detected by checking. Let's start with the x coordinate first of all. If it goes past the graphics devices viewport boundary on the right. Oops. The viewport is a rectangle. The viewport is where you're drawing, and it has a rectangle in it called the bounds, which tells you the x, y, width and height of the viewport. So we can get the right hand pixel. So if the x coordinate goes past the right hand pixel in the ball's direction, becomes what it was before, multiplied by -1, it'll bounce back. And you might be thinking, well, we can make that, use a compound, and you're right, compound multiplication. Do the same thing for the left hand. If ball position.x is less than, it could be lazy here and say 0, but I'm going to be it consistent. Graphics device, viewport bounds, left. Ball direction times equals -1. And then top and bottom, ball position.y this time. If it goes past the graphics device viewport bounds bottom. And then ball direction, oh sorry, I forgot. It's not the whole direction we want to reverse, otherwise it will tombstone back the exact same way it came. We just want it to reverse horizontally, which is .x in the left and right bounds. But in the top and bottom we want it bouncing off vertically. And finally the top of the screen, which again should be 0, but let's just be consistent. And if you've done any programming before, you might have noticed, well, we can probably combine these two and these two. And you can, but I'm going to leave that for another time. Right, so let's run that. This is not going to be the final version of that collision code, but it does bounce off. Did it look a bit odd to you? When it hits the top and bottom, it's fine. Sorry, the top and left hand side, it's fine. But the bottom and the right hand side, it does kind of slightly go off still. The reason for that is the x and y coordinates are the x and y coordinates of the first pixel of our image. The final pixel is to the right and down of that. So to solve that, we could probably say on the right hand side ball position x plus ball image dot width, and same for the y at the bottom. Not at the top, because those are fine. It's the top left corner that's used as the x and y anyway. Oops, put a dot there instead of a plus. If I've done that correctly, it should bounce more smoothly. There we go. But we only want that to really happen at the top and bottom. The left and right should instead result in somebody scoring a point. So let's put scores in. Score for player 1, score for player 2. We'll also need to be able to display them on the screen. So did I put a font in here? I can't remember. No. Let's add a font. Edit, add new item this time. That's going to be a sprite font. It defaults to Arial, which is great. I'm going to use Arial. Be careful of copyright on your fonts, but I'm not going to be distributing this, so I think it should be okay. So we have a sprite font called Arial, but it's not loaded into memory, so let's declare a sprite font to load it into. I'm going to call it main font, not Arial. You could make it match the same name, but it doesn't have to. So the main font for our game is going to be loaded in from the content pipeline. Just like we loaded the textures, except we obviously tell it to load a sprite font instead, different type of thing. And now in the draw method, we can use another command called spritebatch.draw. Oops, I've used a capital S. So a capital S, you may have noticed, gives you the spritebatch class, which doesn't exist. It's only used to create sprite batches. And lowercase s happens to be the name of the sprite batch we created, which actually exists and we can use. So instead of draw, it's drawString. You need to tell it, as you can see from the pop-up, a font to use, main font, some text. I'll concatenate that in a moment. Where to draw it, which is a vector2. Draw it in the top left for starters. In fact, no, I'll draw it slightly in from the top left, give it a little margin. And which colour you want to draw it in. That will test whether our font code is working right. Yep, there's the score. So this is the score. It's going to be the score for player 1. So P1, and we concatenate that with the actual score 1 variable. So player 1 has 0 points. So then we want to draw player 2's score using the same font. Very similar code, but it says P2 plus score 2. Now, as for its position, we could put in 1024.768, which is the other side. Oh no, sorry, we don't want it all the way down the screen. We'll make it 10 to match the other score, but horizontally it's 1024, which is the edge of the screen. And don't forget colour black. What's wrong with that? Well, it's not there. Actually, what's happening is it's trying to draw the score over here, just outside the screen, because again, those x and y coordinates are the top left corner of it. If I bring that back in a bit, just eyeball it, 924, there it is. But if we want it to have the same margin as the first one, we can work it out programmatically. You can take the width of the screen and subtract the width of the text from it. That's just as complicated as it sounds, so I'll put it on its own line to keep things straight in your head. It's the x coordinate we're worried about. We get the graphics device viewport width again, but we subtract from it the main font measure string. So it's going to measure the length of a string. We need to tell it what string it's measuring. So this has to match the string that we're drawing, because if you measure something else, it'll give you a different size. So P2 plus score 2 is what we're drawing. You need to measure the length of that string, but measure string gives you a vector 2, and we're only working on an x coordinate, so we just do .x to get only the x part. And yeah, I did say it's quite a mouthful, that line. We could probably split that up again, I think. There we go. So we draw in the main font this bit of text, and its position is worked out as the width of the screen minus the width of the text, so it brings it back that same amount. I think that's probably going to be on the screen, but quite close to the edge, because we forgot that 10 pixel margin that the other bit of text had. So let's subtract another 10. That seems like a lot just to get some text on the screen, doesn't it? But that's just the way XNA is. It's not designed. Console uses the right line, but I think it's worth the trade-off to be able to have graphics and sounds and whatnot. Okay, so next, as I said, we want to make the ball respawn when it hits the left and right, instead of just bouncing off. So let's actually refactor this bit here, which gives the ball an x and y coordinate, because we can reuse that code. Instead of just duplicating it, we're going to refactor it. Oh, sorry, I'm too used to the 2013 version. Here are extract method. Let's call it spawn ball. So now the initialize tells the ball to spawn, which runs this code and then comes back and carries on. I'll not put the direction in, because the direction might change when it respawns, but the position, these 4 lines tell it the middle of the screen. So now we can reuse spawn ball to make it respawn. Let's do that. Well, it kind of respawns a bit too soon though, doesn't it? It respawns when it hits the edge. And that was how we wanted it to react initially. But now we want it to go slightly past the edge of the screen before respawning. So at the right hand side, I guess we no longer want to add on the balls width like we did before, that's what fixed it earlier. But we do want to do that here, just to let it go a little bit past the edge of the screen on both sides. Now if this guy's just lost a point, it doesn't make much sense to have the ball come straight towards him either, so let's reverse the ball's X direction, and when it respawns it will go back towards the other player. Okay, we now have a working ball, but the score is not incrementing. It's a simple matter of giving a point to player 2 if it goes off the point to player 1 if it goes off the right hand side, and a point to player 2 if it goes off the left hand side. You should start to see those numbers go up now. 1 point to player 1, 1 point to player 2. It's not really a game yet because you can't hit that ball, but now the ball does do what it's expected to do. Let's work on a bat then. Because we did this work of making a sprite class earlier, now we can just say sprite bat equals new sprite, and it's already got its own image, direction, position and colour. But the image is empty, so let's load in it something in. Bat. In fact, you know what, I'll call it player 1 bat. Oh, and here by the way, wait till I finish this line, I'll do that. Bat.image equals content.load, loading a texture 2D, and the name of the file, I've got it written down here somewhere, hang on, pongbat. We can then draw that. Sprite batch.draw bat.image in bat.position using bat.tint. That should work. Not having set up a position though, it will be 0, 0, top left corner, there it is. And of course no collision yet, it's not coded. But if there's going to be a second bat later on, that could get confusing. So let's call this p1 bat. And notice when I rename the variable, when it's declared, we get this option to potentially fix all of the other code that accessed bat by changing it to p1 bat. You can see the red line, which is now wrong, and the green line, which is what it will fix it to. Everywhere bat was used, it will become p1 bat, which is really handy if you want to rename your variables. So what should player 1's bat's position be at the start, the initialize? p1 bat.position should be a new vector 2 with x and y coordinates. I'm going to make the x 10, just a small indent from the left. And the y coordinate we will calculate again. Get the graphics device, viewport, and take the height divided by 2. That's halfway down the screen. But we can't leave it at that because that's slightly off center due to the fact that the y coordinate is the middle of the bat. So take the bat itself, get its image height, and divide that by 2 as well. So now the middle of the bat spawns in the middle of the screen, vertically. Here it is. Okay, then I guess the next step is to get it responding to the player's keys like we did in the console example. So this is in the update. And I'm going to say if the keyboard, which is an object used to access the keyboards, not unsurprisingly. If we get the status of the keyboard, that's a command, so that's empty brackets, and that will return a keyboard state. Keyboard state has attributes such as, attributes and methods such as is the key down, which means have you pressed the key down. Which key? Well, it's keys.w. So that's saying if the current status of the keyboard is that the W key is pressed down. So if you're holding down the W key, then player 1's bat position on the Y-axis will be -4. And if keyboard.getState.is key down, oops, can't type, fat fingers, keys.s. If S is pressed, the player wins bat. Oh, 1 pixel is garbage actually, let's make it 4. And the Y coordinate, wait a minute, that's wrong, isn't it? We'll make it +4 just now and you'll see why it's wrong. There it is, in the middle of the screen. I press down. Oh, up and down just toggles between those two positions. It's the same mistake I mentioned not that long ago. If you say equals minus, that's a different thing from saying minus equals. Equals minus just sets it to -4, whereas if you say minus equals, that means it reduces it by 4. Same thing here. So we add or subtract 4 pixels on every frame that those two keys are held down. Yay, a moving bat, which does nothing. Also, by the way, we don't have the same code that the ball has to stop it going off the screen. And in fact, we shouldn't have exactly the same code. It will be similar, but slightly different. Because the bat doesn't bounce, obviously. So if p1 bat dot position dot y is greater than graphics device dot viewport bounds bottom. If you hit the bottom of the screen, then don't make it bounce off, just change its y coordinate so that it is equal to graphics device dot viewport. You know what, I'll copy and paste. So if it goes past that pixel, then make it equal to that pixel. That's clamping it, stopping it from going past that pixel at the bottom of the screen. But is that what you want? Not quite. It goes just past the edge of the screen. Again, the Y is the top of the bat. Now we don't want to do the adding on here because then it makes no sense to add on there. So let's subtract it from here instead. A little bit of math there for you, a bit of algebra. Subtract p1 bat dot image dot height. So now the boundary is brought back a bit by the height of the bat. Don't forget to include that in the clamp as well. And voila, stops at the edge. We could, if you want, even put a 10 pixel margin in. Okay, and the top will be very similar but a bit different. If it goes less than top of the screen, and we don't need to do the minus anymore, but we should probably add on the 10 pixel boundary again. So if you go below that pixel, then stop at that pixel. And you can't go off the screen. In fact, you can't quite touch the screen edge either. And it's now ready for some collision detection. And that is a big deal. I would say collision detection is the second hardest thing for beginner game developers after AI, in my experience. But we'll give it a go. Oh, you know what, actually, before I do, let's make that movement a bit smoother. Because as soon as you let go, it's a bit jerky. It comes to a complete stop as soon as you let go. Let's use that direction. We've got it there. Why not use it as a sort of acceleration? We use acceleration on that direction. So instead of directly changing the coordinates of the bat, we are instead going to change the direction of the bat, which on its own will do nothing until you do the same thing you have with the bat as we did with the ball. Take the bat's position and add on its direction. So because that direction gets added onto every frame, it will accelerate and decelerate, but it will go quite a bit faster. So let's scale that down a bit. 0.2. Don't forget the F because it's a floating point, not a double precision number. A more reasonable sort of acceleration, but if you let go of the key, it keeps moving. So let's apply some friction to it as well. Whether you apply the friction before or after the actual movement does affect how it works. but not to a huge amount at this stage. So we're multiplying it by 85%. It's going to lose 15% of its speed every frame, which is 100 frames per second. Now it's too slow. But I mean, these are just values you can play about with. Let's say 0.8 perhaps. Yeah, it looks a bit smoother. You might not be able to tell it from this video, but it definitely feels smoother to play. Our code for the update is getting a bit long-winded now. Let's refactor it purely for readability. Take the things to do with the ball. You can hold down shift and arrows, or you can click and drag, or you can click and scroll the mouse. So this is all to do with the ball moving and bouncing. If we extract that as a method called, let's say, move ball, and this is to do with the player, or player 1 I should say, player 1 bat. Let's extract that. Move bat 1. So now our update is a bit short. All that code has been stuffed into these two methods, which we can minimize until we need to view them again. And our code's much more manageable. Okay, now the big deal, the collisions. There's a few different ways to do it. I am going to do it using rectangles, which you have briefly seen before. Let's add a rectangle to this sprite class actually. Public rectangle, and we'll call it its hitbox. We need to keep those up to date. So during the ball's movement, after the ball has moved, we will update the hitbox. Ball.hitbox equals, it's going to become a new rectangle, and the x and y coordinates will be the same as the ball's x and y position. That makes sense, that's where it's coming from. Look at those turn red. When you make a rectangle, it is expecting integers, int x, int y, int width, int height. But the vector x and y are floating points. So we need to cast them, remember casts? Turn them into integers by putting a cast in front of them. So that's x and y. We also need the width and height, which we get from p1bat.image.width and p1bat.image.height. Those are already integers, so no conversion needed. You can split that line up if it's getting a bit hard to follow. Oh wait, I've skipped, sorry, not bat, the ball. Yeah, we're making the ball's hitbox, so we use the ball's image. But I mean, to be fair, we can use exactly the same code for the bat. So where's the movement of the bat? There it is. So instead of ball, we'll just be p1 bat here and everywhere that it refers to the ball. Modularity, that's one of the reasons we use it. It's so easy to reuse things. Okay, so now they both have a hitbox, a rectangle. And let's go back to the update and actually use those things. So we can say if the ball's hitbox intersects is a method that every rectangle has, and you can pass it another rectangle and it will give you a true or false value telling you whether they overlap. So if the ball overlaps with the hitbox for bat, let's hit the bat and we should make it bounce somehow. A simple example would be take the direction and make it equal to the negative of itself, so it will reverse direction. Oh, I missed it, typical. Yeah, but there's a tombstone, that's the kind of thing I mentioned earlier, it just jumps back the way it came. Easy solution, make it go back only along the x-axis. Much better. But what happens if you hit it on the edge? It gets stuck. Did you see that get stuck in the middle for a while? And it kind of randomly goes whichever way it wants after it comes back out. That's because if it comes down from vertically and we make it reverse direction horizontally, then it's still hitting the bat and it will continue swapping directions until it gets to the bottom of the bat. So A slightly better approach would be to make the ball direction x, same as it was before, get the absolute value using the maths class. The math class is just a whole bunch of handy methods. Don't forget to use system to get at it. There we go. Took its time there. The absolute value, or ABS, takes just the magnitude of that variable. If there's a plus or minus sign, it discards it. It becomes a positive value. So it's always going to have a positive value along the x-axis. And given that we're on the left-hand side of the screen, which tends towards 0, a positive number will make it move the other way. If it hits the other bat, obviously, you would do the same thing, but stick a minus sign in front of it to reverse it. And that's good because it means that even if you hit the edge of the bat, it's always going to go back the other direction. It's not perfect because the ball does sort of go through the bat a little bit in that case. But that's now playable. I guess we could expand on that. Let's put in the previous hitbox. Rectangle. So this is going to store where the sprite was before it moved. And we need to keep them up to date as well. We do that just before updating the current hitboxes. So where is that? Move bat has at the bottom hitbox update. So just before we change its current hitbox, we store it. The previous hitbox is going to be the hitbox where it was before it changed. And the same for the bat, the ball, beg your pardon. I should say ball hitbox. So we're keeping track of where the ball was the previous frame before it moved. What good is that? Well, if you know where the ball's coming from, then you know what direction it came from, and you can calculate different ways to bounce off instead of always bouncing the same way. Because it'd be nice not to have the ball move through the bat like a ghost, instead bounce off vertically. Okay, so next thing is, if there's an intersection, check all the previous boxes to see what direction it came from. Where's that? It's back in the update, isn't it? Let's minimize these. And there we are. Ball, hitbox, intersect, bat, hitbox. So there is a collision. We do need to do something about it, but that will depend on where it came from. So if the previous hitbox, if the top of that hitbox was past the bottom of where the bat came from, I'll try and explain that in a moment. Let me just finish off this consequent. Hit from the bottom. Because if the top of one hitbox goes past the bottom of the other hitbox, sorry, if the top of the previous hitbox is greater than the bottom of the other object's previous hitbox, then that means where our ball came from was below the bottom of where our bat came from. So previous frame, it was underneath, in other words. So we hit it from beneath. Kind of difficult to wrap your head around that, but it does. It says that the top of the ball used to be below the bottom of the bat, is underneath it. And in that case, what you should do, the way you should respond, is by taking the y direction and making sure that's positive by using absolute. It's going to bounce downwards. But if the ball's previous hitbox, if the bottom of it was above the bat's previous hitbox top, I'm actually going to add in a 1 pixel boundary here just to be on the safe side. So if it came in from the top, then, oh, you know what, then we'll just make sure the y is an absolute value reversed with a minus sign. Oh, and it's usually a good idea when you've got multiple if statements to chain them together with else's, otherwise there's a chance you could run multiple if statements. So we've got the right and left to deal with still. Ball, previous hitbox left was to the right of the bats, previous hitbox right. And if you're following this, you should figure out that means we've hit it from the right. And in which case the ball's X direction should be positive. And finally, the ball's previous hitbox dot right is less than or equal to the bat's previous hitbox left. Then it was hit from the left. Copy and paste. And that's going to replace all this. Well, all that's going to replace this one line, but that's going to make it bounce a little bit better. Now, if it hits the edge of the bat, it should bounce up and down off of it instead. I'll try and position it so that will happen. There you go. That's definitely an improvement. But watch what happens if it's moving when it does that. Try and get it in. Could you quite see that there? It kind of. It's not a big problem, but it did kind of tug it along slightly inside the bat. Maybe if I slow down the frame rate, you could see that a bit better. Okay, so at 20 frames per second, oops, better start moving. If I hit it, hopefully I can time this right. If I hit it while moving, you can still see it goes through the bat a little bit. I actually wouldn't be concerned about that. You know, it's close enough. Games don't have to be perfect in terms of physics. But if you do want to fix that, it's not too hard. Just that when you hit it from the top or bottom, because that's the way it's moving, as well as changing its direction, just give it a little nudge. Make sure that the Y position is based on the Y position of the thing it hit. Now I'd need to add on the height to get to the bottom pixel of the thing it hit. And add on the direction that the bat is making it move in. That'll take account of the speed of the bat when it hits the ball. Same thing from the top, but instead we'll subtract the ball's image height because it's the bottom pixel of the ball that we're worried about. I don't know if you'll even notice that change, but it is technically slightly better. And that's collisions. One last thing we're going to do is refactor that. So let's take all that code and extract a method called bat collision. Now we are going to have two bats. Do you want to have to rewrite all that code for the second bat? I wouldn't. Why don't we make it so that you can pass in two sprites, the bat and the ball, and let it work out the rest? As soon as you put in those parameters though, it's going to give you an error because there's no overload for that method. There's no version of bat collision that takes two parameters. Well, let's make it take two parameters. We have a sprite, oops, called bat sprite, a sprite called ball sprite. So we're going to use these two names for the bat and the ball within our bat collision. So actually a short way to do that would be still use P1 bat, the same name, and ball, the same name, but then change them, because then you have access to this fix thing that will change them all. See, all the P1 bat becomes bat sprites. Ball sprite. Fix them all. So there we go, all our code is now generic. It can be used with any bat and any ball, which might come in handy when I leave you to do the other bat. Okay, well that's pretty much it. Oh, you know what? I put some sound effects in here, why don't we actually use them? Bounce sound 1, bounce sound 2, score point. So declare 3 sound effects. Bounce 1, bounce 2. In fact, we may as well make it clear that these are sounds. And point sound. The audio is not already being used. Okay, well let's click it and make sure it uses the audio library. The sound effect should turn blue. There we go. So we need to load them in, as you might expect. Let's load content again. Bounce sound 1 equals content load. Release sound effect. Bounce 2 sound, a different file, and finally the, well, what was the third one called? Point sound. Let's make sure I get the file name right. It's called score point. We now have 3 sound effects ready to play. You need to be very careful where you play them, because if you play them at the wrong time, it'll play the audio every frame, so you get 60 sounds playing at the same time, and it'll sound like garbage. So where would be the right place to play it? Well, I guess the collision. If you detect a collision, then we could play the bounce 1 sound. But if the ball is moving and it hits at the top or bottom boundary, then we can play bounce 2 sound. Top and bottom. And finally, when somebody scores a point, point sound please. Hopefully I have done that right. Yep. Okay, our retro Pong clone complete with sound effects. There's no second bat moving, there's no second bat loaded or drawn, there's no second bat collision. So I'm going to leave you to deal with all that. Hopefully you have the ability to do that by now, and I'll see you next time having done that.